So let's jump straight now to the topic of El Nino, which is obviously very broad. We'll cover it a little bit, and then I will briefly mention how the other oceans work in terms of this tropical mode of variability. This is showing the sea surface temperature during an El Nino, which basically have to be compared with the sea surface temperature that you are familiar with now, where you had the West Pacific warm pool, very warm waters on this side with deep convection and so on. And here we had the trade winds creating Ekman divergence and upwelling, so we had cold sea surface temperatures throughout the year, with the ocean taking up the heat in response to that dynamic upwelling. Once in a while, those warm waters slush to the east. We don't know exactly why, in fact, and then it warms up here. The deep convection over the warm water also moves east along with it, as we will see. So these regions, which are typically dry because of the cold water on the coast, like California down into the South American countries here, Peru, Chile, and so on, especially Galapagos, they become very wet with mudslides and lots of rainstorms and landslides and so on and so forth. But you also know that the upwelling here causes the cooling. So if it is warm, that means the upwelling is reduced. So you will affect all life forms that depend on the upwelling, the photosynthesis, and the rich biodiversity, fish and so on. For example, these are the Galapagos Islands, which are obviously famous for the epiphanies that Darwin had when the Beagle stopped here for 3 months. Apparently he was not a happy camper on the ship. He used to get very seasick, so he was very happy to be on land for 3 months. And there are things like these iguanas which have evolved to actually account for El Nino. What do they do during an El Nino? Because the upwelling is reduced, primary production or photosynthesis reduced, algae biomass is reduced, they shrink their body by almost 50% to survive the El Nino years when food production is greatly reduced. Okay, so since the heating and the deep convection, the Hadley cell, and we will see something called the Walker cell, connect the heating here throughout the globe. Obviously, during an El Nino, you perturb that system, then you also affect weather around the world, not only along these coasts here, but also here, or India, or East Africa, South Africa, Brazil, West Africa, and so on and so forth. Okay, so El Nino is a powerful monster that moves heat sources and creates lots of good and bad around the world. So let's look at the schematic of our normal conditions, where we had trade winds, we had coastal upwelling and equatorial upwelling. Associated with that, we said the thermocline gets lifted, so we have upwelling there. The water is pushed to the west by the trade winds in the south equatorial and north equatorial currents, piled up here against the coastlines. You get a deeper thermocline, and during normal times, the ocean is soaking up heat and expanding the amount of warm water here. It's called a recharge phase, where warm waters are accumulating, and then when an El Nino happens, those warm waters are released to the east. So the rising air we have talked about in a zonal mean meridional sense, where we kept saying that the Hadley cell moves energy to the north, but the rising air hits the tropopause. There is also a divergence in the zonal direction, so air also goes to the east and sinks over the cold waters where there is subsidence, high pressure, clear skies, and so on. Remember, clear skies, high pressure means no rain, right? The nice weather, of course, with cold waters. Tropical ocean with very cold waters, 20 to 23 degrees centigrade. Not much fun. So here you get this warm water building over time. The Walker cell, the name comes from Sir Gilbert Walker, who was a officer in the British service in India in the late 1800s, early 1900s, and he was worried about droughts and famines in the monsoon, and he sat down and tried to figure out what was happening. Okay, so he saw that the pressure data from Darwin and here in the South Pacific from Tahiti were out of phase. So when it's cold here, there is high pressure here, this is warm here, this is low pressure here. Once in a while, this became anomalously low, anomalously high, this became anomalously low, and that seemed to correspond to the droughts in the monsoon. So he called it the Southern Oscillation because both Darwin and Tahiti are in the south of the equator, right? So it's only after a long time in the 1960s that Jakob Birknes figured out that actually El Nino and the Southern Oscillation are the same. Where does the name El Nino itself come from? It turns out that these warm waters here appear around December, January, February, around Christmas time. The Spaniards who colonized these places thought this was warm water replacing the cold water during Christmas, and it was a gift from God. The Christ Child, they called it, El Nino in Spanish. We'll see that there is an opposite phase where things get colder than normal, and obviously we cannot call it anti-El Nino, that would be Antichrist. So we call it La Nina, the name that was brought up by a guy called George Philander from Princeton University. Okay, so that's the normal condition. I will stop this here and go into the El Nino conditions in the next podcast because this is long enough as an introduction. So El Nino happens around December, January, February. The main feature is the abnormally warm waters off the coast of South America, which is normally cold. And you will see there is slight cooling in the west, and rain and mudslides, landslides on the east, but droughts and dust storms on the west. Reduced upwelling in the east because the warming is associated with weaker trade winds and weaker Ekman pumping, Ekman divergence, and weaker upwelling, Ekman suction. Okay, weaker because there is a feedback between the convection moving, trade winds weakening, upwelling reducing, sea surface temperatures warming, and further favoring this process to continue. We will see how that happens. Okay, but we will also see that the El Niños are not just always warming in the east. We have found out recently that El Nino can also happen in the central Pacific or more to the western Pacific. Basically, it corresponds to the perturbation of the deep convection in the warm waters over the west. Okay.